Hello, algebra students. I've got some review problems for you to try. So please pause your video and try 1, 2, and 3 on your own. Okay, go ahead, pause the video. Okay, now pause the video again and check your work against my work and make sure that you understand slope and direct variation. Okay, today's lesson is from Chapter 3, Section 5, where we're going to be talking about arithmetic sequences. And they will be linear because that's what this chapter is all about, linear functions. So, arithmetic sequence. A sequence is a series of numbers that follows a pattern. That is the definition of a sequence. All right, a term is the number in a sequence. Arithmetic sequence increases or decreases at a constant rate. There's that phrase again, constant rate. All right, the common difference is the rate of change in a sequence. Okay. Now, there is a formula for finding the nth term in a sequence. N stands for if I want to find the 8th term or the 9th term or the 10th term. N is what term I'm looking for. So I want to come back to the formula. So flip over to the back page, please. Let's look at the box at the top of the back page. An arithmetic sequence is a numerical pattern that increases or decreases at a constant rate called the common difference. Let's look at a sequence before we talk about that formula. Here's a sequence. It goes from 3 to 5, from 5 to 7, from 7 to 9, from 9 to 11. The common difference here, they're increasing by 2. Increasing, so it's positive 2. So their difference, if you said 5 minus 3 is 2, 7 minus 5 is 2, the difference is 2. D stands for the difference, the common difference. All right, here this pattern's going down. So notice that they're negative 4. From 33 to 29, if you said 29 minus 33 is going to give you a negative 4. So you always take the second term and subtract the first, the third term minus the second, and so on. So when you of course, 33 is getting smaller, so it's negative. The difference is a negative 4. In this example, 21 is the 1, 2, 3, the 4th term. All right. What number is 11 in the first example? 1, 2, 3, 4, 5. It is the 5th term. Those stand for N. N, the number term that it is. So if you go back to the formula on the front page, here is the formula, and it says A sub n. If you're looking for the 4th term or the 10th term, n is the number term that you're looking for. Okay, you'll take a sub 1, which is the first term. You're going to add to it whichever term you're looking for. If it's the 7th term, you'll say 7 minus 1, which would make 6, times d, and d here is the common difference. So you might want to write this formula when you get ready to do the practice problems. You want to write this formula at the top of the page so you can practice plugging the right numbers in. So let's look at an example. We're going to take baby steps. First, it's asking us to determine the pattern or determine whether or not there is a numerical pattern. So we'll say 4 minus 2, so I increase by 2. 8 minus 4, that changes by 4. Right there I can stop. Even though 10 minus 8 is a positive 2, there's not a common difference. We went from 2 to 4, so no, there's no pattern, no common difference. Okay. Negative 15 to negative 13. You'll say negative 13 minus a negative We'll do looking for the change. So it increases by 2. Increases, yep, because it went from negative 15 to negative 13. That's going positively on the number line. This one increases by 2. This also increases by 2. So you would say yes, the common difference, or let's start using D from here on out. D equals 2. The common difference, D, is 2. Now we have some fractions. So let's practice our fractions. 1 minus 1/3 is going to equal 2/3. And then 4/3 minus 1. Make that into, let's change that to 3/3. So that's going to be 1/3. Wait a minute. 2/3, 1/3. So we'll say no. No common difference. Okay. Now we're looking for the next term. If we can see the pattern, the common difference here was found by subtracting successive terms. So negative 11 minus a negative 8, that makes a negative 3, a negative 3, negative 3. So what's going to be next? Negative 17 minus 3 is going to be a negative 20. Negative 20 minus 3 is going to be negative 23, negative 26. Oops. So I was able to do that without the formula. So let's see about the next one. Let's see if we can find the common difference. 63 minus 58, that's a difference of 5, and we're increasing, getting larger. This is another difference of 5, a difference of 5. So if they just want me to find the next term, I will say 73 plus 5, and the next term here is going to be 78. Okay, little a says find the 26th term. Well, 1, 2, 3, 4, 5. I found the first 5 terms. So to find this 26th term, I will have to add 5 21 more times. And I think there's got to be a better way. Is there a better way? Yes, there is. So flip over to the next page, and that's where this formula is going to come into play. If you're looking for the 26th term, to prevent sitting there and adding 5 each time, we can use this formula. So for the next example, it says write an equation for the nth term, not the 26th term, any term that I'm looking for this arithmetic sequence. Well, remember, n stands for the number of term. So here's n. I do not know what it's going to be. So n, all right, so n is going to stay a variable. And we're writing just a general equation. My first term, which is a sub 1 here is 1. So in my general equation for an arithmetic sequence looking for the nth term, a sub 1 is 1. Plus, I do not know what number term I'm looking for, so n represents the nth term, minus 1. And then D here stands for the difference. So what is my difference? What is my constant or common difference? So we need to do that math to find our D, the difference. So 10 minus 1 makes a positive 9. 19 minus 10 is a positive 9. 28, so it's increasing by 9 each time. So D is 9. I can simplify this equation, so I'll put 1 plus, don't forget to distribute your n, your 9. 9 times n. 9 times a negative 1 is a negative 9. We can make this even more simplified by saying a sub n equals 9n minus 8. That equation will give me the nth term. So go back to that other example. If I wanted the 26th term, I would turn n into 26 here. But they didn't ask us to find the 26th term. They just want a general equation for the nth term, and this would be our answer. But next they're going to ask us to find the 12th term. So I'm going to take that equation and let's plug numbers in. So I'm looking for the 12th term. N is 12. That was my only variable. So now in place of n, I'll replace it with 12 minus 8. So 108 minus 8, and the 12th term is going to be 100. All right, which term of the sequence is 172? Uh-oh. So now I know the term ended up being 172. So the final result was 172. That was what number? So now I'm looking for n, and I know, so back to this is the 12th term is 100. Okay, well, which number term is 172? So I'll have to add 8 and 9n equals 180, divide by 9, and n equals 20. So what is 20? It's the 20th term. 172 is the 20th term. That would be your answer. I found n, the nth term. All right, graph the first 5 terms of this sequence. So in our equation, a sub n equals 9n minus 8. A sub n is the same thing as y, or f of x, and n is our independent variable. The dependent variable depends on which term I'm looking for, so x is n. So in place of n, I will substitute 1 through 5 because they wanted the first 5 terms. So for the first term, 9 times 1 minus 8 is 1. 9 times 2 minus 8 is 10. 9 times 3 minus 8 is going to be 27. Minus 8 is 19. 9 times 4 is 36. Minus 8 is 28. And 9 times 5 is 45. Minus 8 is 37. And they've asked me to take these first 5 terms and to graph them. Well, when you look at the graph, 37 is how high I go on y, and I only have 10 here, so I'm going to have to be creative. And let's go up in increments of 10. Let's make that 10, 20, 30, 40, 50, 60, 70, 80. Let's add, go up and multiply by 10 so that I can fit everything on my graph. So 1 is going to be very small right there. And then 2, 10, 3 went up to 19, not quite to 20. 4 goes not quite to 30, a little farther down, closer to 28. And then 5, 37. So our outcome here is a straight line, or it should be. And I have that here at the bottom of the notes. The points fall on a line. The graph of any arithmetic sequence is linear. And the first person who comes in tomorrow and tells me why an arithmetic sequence is linear, I will give them a good work. As you turn over to the back and try those real-world example problems, remember for arithmetic sequence, the first thing you need to do is find the common difference. If there's not a common difference, then it is not an arithmetic sequence. Here is the formula provided for you here. So you will need to use that formula to answer both A and B. And I just want to review here, I asked you for the domain. Here's your hint. Domain means what are the x values. So this is a review question that ought to be fairly easy to you. And just a little fun fact, this is my favorite time of year because I love pumpkin pie. Have a great day.